Assalamu alaikum and hello everyone. This is Dr. Bilal with the Introduction to Programming using C++, a step-by-step approach. We're going to discuss in this lecture the flowcharts. Starting off, we're going to define the flowcharts first, and then we are going to identify different components that actually make the flowcharts. Why flowcharts are important? Why should we actually go for the flowcharts before we actually make a program? How can these flowcharts be used for developing the pseudocode and the basic algorithm of any problem that is actually presented in front of us? So whenever there is a problem that we encounter, if we have to actually develop a program, we must understand that the problem, the solution to the problem is basically the certain steps or the certain activities which actually are represented in a certain flow. If we actually look at the basic definition of the flowchart, we can actually see that the flowchart is a sequence of block diagrams which shows the flow or the sequence of events, activities, and workflows. So over here in this definition, we can see that we can actually see the sequence. And then we can see the block diagrams over here. And then we can actually see that these block diagrams or the sequence of block diagrams show the flow or the sequence of events, activities, and the workflows. So we are going to see these block diagrams, or there are different blocks that we use to represent different purposes. These blocks will be actually connected together to give a certain sequence of events. So if we actually see the number of the blocks that we are going to use, or if we see different blocks that we use, we can see over here that this oval shape over here is a start or a stop. This rectangular is basically a process. This parallelogram is used for input and output. And this diamond shape is actually a decision box, which has two offshoots. One is towards yes, and another one is a no. So this decision box is basically a sort of a condition or a conditional statement. This is where we actually make a decision whether to actually go for, or if that condition is true, the sequence is going to actually show a shift or go towards the yes. If the condition comes false or which is not true, it can actually go towards the no. For example, if we say that in case that if age is greater than 18, you can actually set in a roller coaster ride. So if you are having, if you have an age of greater than 18, and if this condition comes out to be true, then the flow is actually going to shift towards the yes. But if this condition is in case, if it is false, then this false will actually flow towards a no. So whenever we use a decision box, we always use the if condition over here, maybe the if condition, and later on we can actually see the switch in case as well. So we're going to actually follow up with this thing as we actually go forward. So over here, we can actually see that there's another one, which is another block, which we have named as a connector. Now, the connector is usually used when there is an end of a flowchart, and we are actually shifting from one page to another page, and there's not enough space to represent the flowchart on the same page. So what we do is we actually put a connector over there, and we can actually place the connector on the next page so that we can actually, we can actually represent that this is where it is ending, and this is where it's starting from the next page. And not only that, but if we actually have two different modules that we are actually developing, or multiple modules that we are developing, and we want to actually connect those modules from one module to another module in a flowchart, we can also use the connectors at that time. So this is actually going to this we'll actually see in our subsequent lectures, that how can we actually use connectors when we actually making the program a flow chart big enough to certain modules. Then there is another a representation, which is a flow direction. Now, this flow direction is more like an arrow over here, that we can actually we are in this decision box showing that if the condition is true, the flow of the flow direction is actually towards a yes. If it is false, the flow direction is towards a no. Similarly, we are going to actually connect different blocks over here, whether it's a start or a process or an input or decision box or a connector, with these flow directions. Let's actually see one of the very basic flow charts over here in the next slide. So this flow chart actually says that we're going to actually start the flow chart from here, and then we are going to have a certain input. So we can see this is your flow direction. So this is over here. We can actually, we are showing that the direction of the flow is going towards from a start to the input, and then we are going to have an input based upon the input over here. We are actually going to process something over here, and based upon the process over here, we're going to have a certain output, and it actually goes toward a stop. So over here, we are not actually using any of the decision boxes, but if we actually use a decision box over here, we can say that, okay, we're going to have a start over here. We're going to start from here, and then we're going to have a certain input. And after the input, we are going to decide based upon the input, maybe, that if this condition is true or not. If this condition within this decision box is true, we are going to actually proceed towards yes, and if it's not true, we're going to proceed towards no. So now what we're going to actually do is that if we are going to actually go towards yes, then there is a process box, then there is an output box, and there is a stop. And same is the case over here. So what we can actually see over here is that these are the different block diagrams which are actually connected to each other through these flow directions, and which are representing the flow of the sequence of different events, right? So for example, this input was an event, this process was an event, this decision box was an event, this output is an event. So these are the different events that which are actually connected together to show a certain sequence. So let's actually jump back to the definition again and see what the definition was. So the definition is that the flow chart is the sequence of the block diagrams which shows the flow or the sequence of the events, activities, and the workflow. So this is exactly what we are doing in this flow chart as well as this flow chart as well. So I hope the basic understanding of the flow chart is clear, that why do we actually make and how do we actually make the flow chart. So let's actually have some more examples related to the flow charts. So let's start up with this. So over here in this flow chart, what we're going to do is we're going to actually add two numbers, and we're going to have a certain output, right? So we're going to start as, let's assume that we have a problem, and the problem is that we need to add two numbers, all right? So let's actually add two numbers. So over here, what we're going to do is we're going to start from here, and then we're going to have defined two variables. Let me actually keep this thing as a y. This is a typo mistake, right? So we're going to have two variables. One is x is equal to 6, and the y is assigned the value 5. Then there's another variable, which is result, which has been assigned a value of 0. So it's an x is equal to 6, y is equal to 5, and then a result equals to 0. All right. So what we are doing next is, now this is an input box. Remember this. So what we are doing is we are having an input of these numbers. All right. So we're having the input of these numbers. Once we have taken the input, based upon these input, we are going to actually process these inputs. Right. So we are going to actually add two numbers, which actually is x is equal x plus y. So logically, what's going to happen is that this 6 plus 5 is going to add up, and this is going to give us an 11, and 11 is going to get stored in the result variable. So if we are going to actually output a result over here, we can see over here that within this process box, once 6 and 5 are added, the 11 is stored in the result over here. After that, we're going to have an output box, right? So this is an output, right? So this is again a parallelogram. We're going to have an output of a result. So because these two, 6 and 5, had got added and they were stored in a result, so this 11 is going to actually be given as an output. So once we have added and shown the output, we actually get we end our program and we say that, okay, fine, we have attained our what we wanted to do. We have actually attained our task. So let's actually stop over here. So this gives us the basic solution to the problem. This is how we actually we can see that this is how we will proceed while we are actually defining our different activities and the flow of our activities, where different events are there. So over here, if we actually go back to the events, go back to the definition, so we started from here. This input is an event that occurred. Now this event is further connected to a subsequent activity or the event, right? And this is another event or an activity, right? So we are connecting from one event or activity to another event and an activity, and even actually giving a flow of a step-by-step approach of solving this problem that we had. So let's actually see this decision box now, and because we had been actually doing a very simple sort of sequence, because this is one of the activities that we haven't seen yet. So we start from here and we actually say that we have an input of two variables, which is x is equal to 6 and y is equal to 5, and then there is a result is equal to 0. So we have three integer types. One is your character sign, because if we want to actually see that, if we want to enter, for example, if we have a calculator, so the calculator may actually add two variables, 6 and 5. It may actually say 6 minus 5. It may say 6 multiplied by 5, and it may say 6 divided by 5. So we are not really bothered with at this point of time, because the basic problem that we have right now is that we want to add numbers. This is our basic problem. So what we want to say is that we are going to solve this problem, right? We don't want a division, we don't want a multiplication, we don't want a subtraction. So within a calculator, when we need to have two variables to be added, or maybe two integers to be added, we need to actually press a plus sign. So if this plus sign exists over there, this means that we can proceed to the activity further to process to actually calculate the overall resultant of this addition, right? So what we are going to do is we're going to simply define these three integers and one character sign, and then we are going to actually put a decision over here. If the sign carries a plus sign over here in the input, if a user says that yes, it is a plus sign, right, then sign would actually carry a plus, right? So if this variable sign has a plus sign and this condition comes out to be true, this means that we are going to head towards a yes, right? And the next activity is the process box, which actually adds two numbers, which is x is equal to 6 and y is equal to 5, and then stores this 11 into the result. And then this is an output box, and we are going to actually simply output the result over here, whatever it was, which in this case specifically, because it's 6 plus 5, it is 11. But if this condition is not true, and if there is a false, and what we do is, instead of storing a plus sign or getting an input as a plus sign, we get, for example, a minus sign, or maybe a multiplication, or maybe a division, or maybe any other letter, then this condition would become actually false. And once this condition is false, this activity will actually go towards a no, and this will output as the wrong input, and the program will simply halt and go towards the stop. So this is how your decision box plays a role in a flow chart. This is how flowchart. This is how the basic decisions are actually made based upon the inputs. So if the condition is true, it would proceed towards yes. If the condition is false, it would go towards no. Moving onwards, if this is another case, if we don't want to have an output of, let's suppose, a wrong input, but the problem remains the same. We want to add two numbers, but in this case, in the next flowchart over here, we want to actually add two numbers, right? The basic, or subtract two numbers. So this is the problem, that if originally, logically speaking, we want to say that there are two numbers as an input, and what we want to do is we want to add these two numbers. But if there is not an addition, at least subtract it. Subtract two numbers. Okay, so we're going to actually start from here. We're going to have an input just like the previous flowchart, 3 integers and 1 character sign, right? And then we're going to have a condition. So if the user at the time of the input enters a plus sign, so it actually would be a true. So if sign carries a minus, it will actually go towards a yes. So if the condition is true, it will go towards a yes, and it will proceed with the process of x plus y, which is 6 plus 5, which comes out to be 11, and which is stored into the result. And the result output over here is going to give you an 11. Okay, right? Because we are adding two numbers, 6 plus 5. But in case, if we enter any other sign, for example, if it's a multiplication, according to this flowchart, if it's a multiplication, if it's a sign negative, if its sign is entered as any other symbol or maybe a letter, the condition is not going to be true. It is going to be false. Okay, right? So once it is false, the flow is going to go towards no. And once it is a no, according to this flowchart, the process box will process the subtraction. Okay, so this is going to this is going to do this 6 minus 5, which is going to end up as a 1, and which is going to get stored in a result. And as an output over here, we are going to get 1 as a result, and the program will actually proceed towards a stop. So there are two different paths. One is, if the condition is true, it is going to add up and give us an output of 11, and then go towards the stop. But if it is not going to, it is going to be a false, it is going to go towards a no, subtract it, give us 1 as an output, and go towards the stop. So right now what we are doing is that we are actually looking back to our problem that we had, and the problem was that add two numbers. If not added, at least subtract those two numbers. Okay, so we have added two numbers, but in case if this condition is false, right, at least subtract these two numbers. So we have actually solved this problem through the flowchart. And you can see this is very simple. It's a very simple approach, right? Okay. let's try one more thing as a practice, and let's see if we actually have more than the previous. For example, it was an addition and then it automatically went towards the subtraction. What would happen if we have multiple choices, like addition, subtraction, multiplication, and division, right? So what we are going to do is we are going to make a problem. So let's see if this is a problem. Our problem says that add two numbers and multiply two numbers and subtract two numbers, all right? But if any other sign is entered, say wrong output. Okay. Okay. So what we're going to do is we are going to add up. We're going to actually start from here. So we are going to solve this problem. So this is a problem with us. So we're going to start this problem. It is going to be a little messy though, right? So, okay, we're going to start from this problem. We're going to have another input as we did before. Okay, so we're going to say that we have three integers, which is x is equal to 6, y is equal to 5. Then there is a result is equal to 0, and then there is a character of sign. Okay, so this is exactly what it is like over here. Okay, then we're going to have another. We're going to actually connect it to a decision box. All right, so, and we are going to see if this character, or sorry, sign s that we had actually taken as an input equals to a plus sign. If it is equal to a plus sign, right? So this is going to give us either a yes or maybe a no. So if the condition is true, it is going to actually process this thing, and we would say result equals to x plus y, which is going to give us a certain output. Oops, sorry. And we're going to say result. Okay. But in this case, if it is a false and it goes towards no, it is going to have another decision box, just like before. Over here, we did not actually add up any decision, right? But in this case, we are going to add two numbers, which can add two numbers, multiply two numbers, subtract two numbers. So this is going to add. But what if the sign that we have entered is not as plus at the time of the input? It might be a possibility that we might have entered a minus. So it's time to put another decision box over here. We're going to actually ask for another decision box or another decision that what if this is false, let's assume if this is false, then what if it's a negative, it's a minus sign. So this is how it actually goes. We start from this place, right? We get in some input of the variables, and we also get an input of a sign over here, right? And then we compare that sign to a plus sign, right? If the sign stored over here is equals to the plus sign, right? This means it's a true, and it is going to calculate it is going to add up, right? But if the sign stored over here is not a plus and it is not equals to plus, we are going to actually go towards a false or a no and see if the sign is storing a minus sign and is equals to a minus. right? And if it is true, we are going to process this box and say that a result equals to x minus y, right? And again, this is going to be an output, and this is going to give you an output of result. But what if it's a false again? So now we start from this place, we take an input, we see if the sign carries is equal to the plus sign. Whatever we have input we have taken of the sign is equals to a plus sign. If it is true, we could add. If no, we check if the sign carries the negative sign and equals to the negative over here. And if it's true, we minus it. But if it don't have a minus sign either, we check again to have sign equals to a multiplication, which is arithmetic. And if it is a yes, it is going to process a result equals to x multiplied by y and give an output of result. Okay. But what if it's a no as well? So now what we are doing is look at the problem again. The problem was add two numbers, multiply two numbers, subtract two numbers. So what we have done is we have made a decision to check whether the sign was a positive. If yes, add two numbers. If no, check if it was a negative sign. If yes, subtract two numbers. If no, check if the sign was a multiplication sign. If yes, multiply it. If no, then there is a last option, which is, but if any other sign entered, say a wrong output, input. It's not an output, it's an input, right? So let me rub it off and just that's wrong input, right? And then if it's a no, so we actually say simply as an output that this is a wrong input that you have. Now, what we can do is we can simply, now that we have actually calculated all the results and everything, so simply put everything over here to the stop. So this all leads to a stop. So sorry for this messed up diagram or the flowchart, but let's actually revise it once. Having a problem that we had to add two numbers, multiply or subtract two numbers. So we added a sign, saw the sign, added it. If it is not the sign, plus sign, check for the minus sign, subtract it. Then if it's not a minus sign, check for the multiplication sign. If it is the multiplication sign, multiply it. And if it is not even the multiplication sign, you just print a wrong input that you have taken. All right, and then the program leads to a stop. So this is another simple approach towards solving this problem through the flowchart. So now we can see that it's the things which were a little sketchy in our mind. Now we are very much sure about this thing, that how do we have to proceed through different activities and the flow of the diagram, that how do we have to actually solve this problem. Okay. Okay. Now, this is one of the practice problems that I have actually created for you for your own good, actually. So you just go through this one problem and try making a flow chart. All right. So if you don't understand anything, you just get back to me and you can ask me about it on my email, on Microsoft Teams, or maybe you can come to my office. You can ask me anyhow. So just take a pause and have a look at this problem and try making a flowchart of your own. Okay, so next is the introduction to the pseudocodes. Now that we have actually ended up with the flowcharts, we can now actually proceed towards the pseudocodes. Now, pseudocode is basically a representation of simple language, either in English, majorly in English, that how do we have to actually solve the problem. So let's actually go through these bullet points so that we can actually understand what a pseudocode is. Um, After the flowchart, pseudocodes are the next step towards the development of the program. Pseudocodes are used to develop the algorithms of the program. Algorithm is a systematic and logical step-by-step approach towards solving a problem. Pseudocodes are a simple form of step-by-step approach towards solving a problem without using any programming language. Pseudocodes are derived from the flowcharts. For new programmers, it is necessary that they draw flowcharts and write pseudocodes to understand how problems can be solved through programming. Okay, so there are a few things which are important in this. One is that the pseudocodes represent a logical step-by-step approach, and they turn out to be a formation of the algorithm. Okay, so this is where your algorithms are formed, and represents the step-by-step approach. All right. So step-by-step approach for any and without any programming language. You don't need a programming language to develop a pseudocode. Okay, and then there is a pseudocode is derived from the flowcharts. This is one of the things very important, that you actually make the flowcharts first and then derive those pseudocodes from the flowcharts. All right, so you must understand that for the beginners, um, it becomes very difficult to straight away jump to any of the IDEs and start developing the code from scratch. So you need to have a pen and paper approach in the beginning, and you need to have the basic understanding of how to develop that program. So in order to have a basic understanding, you need to follow the flowcharts, and you need to understand how to develop a pseudocode. So if you keep on practicing the flowcharts and pseudocodes and then start developing the program, I'm pretty much sure that over the period you are going to develop skills which would not require your pen and paper approach anymore, right? But for the beginners, it is very necessary to have a pen and paper approach and start developing the flowcharts in the beginning and then making the pseudocodes. In fact, uh, primarily, when you actually talk about the flowcharts, the basic understanding of engineering your program or solving the problem, you need to have some sort of an architectural diagram. And the flowcharts and the pseudocodes are something which are always required either by the professional programmers or maybe the beginners, right? So because that actually determines the basic architecture of the program. So you must have a basic understanding of the flowchart as well as the pseudocode, and practice these pseudocodes and flowcharts as much as possible. So this is a sample pseudocode. Over here, we can actually see now this pseudocode is from the flowchart. If we actually go back and we actually see this over here, we can simply see this program like this, that we start, and then we took an input that we added, and then we had an output, and then we actually stopped. So this pseudocode represents the same program. So this is from where we start the program. Take an input of integers x, y, and result. You can actually write down an input or take input, right? Which we have actually written over here. That is input equals x is equal to 6 and y is equal to 5. Over here, we have initialized. So if you want to write initialized over here, simply write an initialization. Okay, right? Initialization of x, y, and a result, which you are assigning the variable 0 over here. And you're taking an input, x is equal to 0 and y is equal to 5. Then we are going to actually have a result of x is equal, result equals to x plus y, which is the basic addition. All right. This is exactly what we did in the flowchart. And then we output, we had actually result as an output, and then we end the program. This is exactly what happened in the flowchart over here. So if we see, we started off, we took an input, we initialized, we took an input, we calculated an addition, stored it in the result, and we had an output, and then we actually stopped the program. So this is exactly what is going on in this pseudocode over here, right? So this is a very simple representation in English or in any language from which you can understand what are the basic steps of, creating a sequence of the program. So this sequence of program is actually derived from the flowchart. So you actually go through the flowchart first. You go and develop the flowchart first, and then start developing the pseudocode. Then similarly over here, this is another example of the last flowchart that we had actually developed over here. This is this flowchart actually, to be very precise. So just keep that flowchart in your mind, just draw it on your paper or somewhere so that this program, the pseudocode actually makes sense. Initially, we start our program. Then we actually initialize X, Y, and the result is equal to 0, and then character sign. Then we take input of X is equal to 6 and Y is equal to 5. One thing that I forgot over here is that we also take an input of sign. Okay, so we input the sign. If the input sign over here is equals to plus sign, this would actually give you the result, the addition result, and we output that result over here, right? But if this is incorrect and this condition is, let's assume, false, okay, this condition, this whole body will be skipped. All right, and it would actually jump to this one. So if this, for example, sign over here that we had actually taken as an input is negative, right, then this condition becomes out to be true. And it is going to traverse through this body. It is going to calculate the result, and it is actually going to give you an output of the result. Okay, right. And then if this is false as well, and the input that we had taken over here was not even a negative sign, or sorry, minus sign, right? So it is going to traverse to the third condition over here, which is actually a multiplication. So if we had actually taken a multiplication sign over here as an input, right? So we had actually taken, like, for example, in the static sign over here, then, and this static sign is equals to the static sign, right? This is going to actually traverse this body, right? And this is going to actually calculate. Now, this is not actually output equals to result. This should be result equals to X multiplied by Y. Okay, right? So this is going to actually multiply and store this multiplication of the result and give you output of the result. But if this is also a false condition, then obviously they were going to actually go towards the else and output this particular statement and then end of the program. And this is exactly what we had done in this flow chart before. We had actually taken an input of sign. If it was an addition, we added. If it is not an addition, we checked for subtraction. If it is a subtraction, we subtracted. If not, multiplication. If not, then a wrong output. And this is exactly what is going on over here in this pseudocode as well. Okay, so having said that, this pseudocode is also giving you the basic algorithm of a step-by-step approach of how to solve that problem, right? And it also has been derived from the flowchart. So it's actually the set of the activities given in the flowchart, which have been represented in a very simple language of how to, develop a certain pseudocode. So that's all from my side. You can, if you do not understand anything and you have any queries about the flowcharts and the pseudocodes, please do let me know on my email. My email and website is given over here. And if you have any questions, please, you can come to me freely. Thank you.